Good afternoon, everybody. My name is Helen Seagrave and I'm the Community Energy Manager at Electricity North West and the project lead for Net Zero Terrace. And I'm here with Phil Proctor from Borough Happel to talk to you about this project this afternoon. So the next slide shows to you the agenda for our presentation, but and also the partners in the project. So we've worked with Borough Happel, Rossendale Valley Energy, Rossendale Borough Council and Northern Power Grid as project partners, but we've also closely collaborated with the Northwest Net Zero Hub and the Centre for Energy Equality. And as you'll see, I'll talk through our headline messages, an overview of the work packages and what our next steps are. So the next slide sort of sets out the problem in a nutshell. We have addressed the innovation challenge that we're all here to talk about, supporting a just energy transition, but specifically how to involve people that might otherwise get left behind with the decarbonisation of heat. So the problem that we're looking to address is one that's faced by many terraced homes with limited outdoor space, where you can't install an air source heat pump because there isn't the space and there's possibly noise constraints. So how do you bring those people and those homes along with the low carbon transition and get them involved with decarbonising their heat supplies? So the Net Zero Terrace street solution is a shared ground source heat loop, which will bring hot water to homes to a temperature that can then be stepped up within the homes by a small air source heat pump. We can offer that to all 10 years of homes. So this is a terrace street where it's not just social housing, it's social housing, private sector and private landlords and owner occupiers. The offer includes energy efficiency measures to make sure those heat pumps will work and community owned energy solar to help bring down the price of energy towards those homes because it's a combined solution. The next slide talks to you a little bit more detail about this, the project summary. So we're working, like I said, in Rossendale, which is in Lancashire, and particularly in a town called Bacup. That picture shows you the streets that's our study area for this. This project was conceived and thought of by the community energy group there, Rossendale Valley Energy. And not only will it be relevant for this area, but there are more than 10 million terraced homes in the UK, and many of them will face the same constraints as identified by this community in Rossendale. And the picture, as you can see, shows you the space issues that are around these homes. The counterfactual is what is on offer to these homes if they don't have this solution is an electric boiler, and that's what we're comparing within this project. And the innovation really is the combination of the technical solution, the financial offer, so it's one standing charge to the homeowners and the households, not just homeowners. It's integrated into the grid. It's not behind the meter or a microgrid or a private wire. It's on the DNO network. And there's a significant level of engagement and buy-in from the community. The next slide gives you the sort of the headline messages that we've got so far from our discovery phase. So the techno-economic modelling shows that this is the lowest cost option for delivering low carbon heat to homes like this. It's currently on a par with the sort of the do nothing option, which is retaining your gas boiler. And we think that once we improve the modelling, it will show we're competitive with that. It clearly will save carbon compared to keeping gas, but it also saves carbon compared to the counterfactual, which, as I mentioned, is the electric boilers. It is a technical solution that is possible. The innovation is around the integration, so it does require more work to de-risk and understand all parts of the components and how they will integrate together. It's possible to integrate it into the network under current regulatory regimes and provide that element of locally owned generation and local supply by using one of the computer platforms that are out there that will help us sort of reconcile charging the householders with locally produced energy to bring down the price to them more. The current connection regime can also deal with this project, so it can be integrated into our network, but it does miss some opportunities to maximise the benefits that the system can provide. So there's further work for us to do to look at how we can best integrate it into the network. And we've looked at engagement plans as part of the discovery phase and developed an extensive plan with a range of tools that can be tested further in alpha to see what will work. So the next slide starts to talk through the work programs that we've done as part of the discovery phase. I've already mentioned really the outcome of the regulatory review and the fact that it is possible under the current regulatory regime, and we don't require any derogations. The next slide was also, the next work package was also led by us at Electricity Northwest, and colleagues looked at how you can integrate it into the network and what the overall impact is on for requiring reinforcement and the connection costs. And you probably won't be surprised to hear that the ground source heat pump solution puts less demand onto the network compared to the counterfactual, and therefore is cheaper to connect. The next slide shows you the community energy strategy as developed by Rosendale Valley Community Energy, which focuses on reaching those people in the community that you need to reach to, engaging them in a meaningful way and retaining them through the lifetime of the project so that they are able to reach the point where they do want to sign up to the solution, they do want to have the energy efficiency measures that they're being offered, and they want to take part in the project. They've done an awful lot of work to develop a very comprehensive strategy, which will be tested fully during the alpha phase to see which are the best engagement methods. And now I'll hand over to Phil from Borough Happel, can talk you through more of the systems architecture and the design.
Next slide, please. So one of the modules we looked at was to develop a spatial planning process to identify where the heat clusters would be applicable, and also to start working out a methodology to work in conjunction with ENWL and DNO in generic terms, in terms of capacity alignment and where flexibility would also play its part. So for this exercise and the discovery phase, we used the Rosendale boundary just to capture an idea of the extent of clusters that would benefit the Rosendale area. We came up with 14,000 households in Rosendale alone. There's a big concentration of terraced homes in the area. And when we used the mapping approach to then understand the extent of the heat clusters, we came up with approximately 300 kilometres of heat network that would be deployed on the back of this process, which is a key point to understand in conjunction with the heat zoning work that's going on at the moment in terms of focus on commercial 4th generation, 5th generation networks that might not be viable in areas like this due to relatively low heat density compared to what those networks typically require. But actually we have a mechanism for rolling out shared heating system at scale, which for areas like Rosendale could be very, very achievable. We also honed down in terms of that particular spatial planning process into then understanding the intricacies of individual clusters and areas. And so we brought the boundary area down to a particular cluster in Bacup and explored that and developed an approach for looking at where the local connection points are, working in conjunction with ENWL on grid impact as a result, and mapping and designing at the spatial context, the scheme in terms of understanding where the rooftops would be to deploy solar PV, connecting that in where the heat network would be, potential areas for EV charging points, communal EV charging points, because there's no off-street parking, and then feeding information into ENWL to look at their network model and where there would be voltage rise issues or thermal issues, and what the potential impact on the network would be under different scenarios. The challenges and areas to look at next time are that scalability and also more automated process of DNO data in conjunction with the spatial planning process to start more quickly designing these clusters, but also to bring in the street works strategy as well, looking at existing utilities, areas for boreholes, and viability around some of those other aspects which require subscription into the modelling process. Next slide, please. In terms of the design review, we looked at a system architecture that would deliver this and the subsystems that would be required to do that as well. So we've identified a system architecture and been soft market testing that with providers as well. Basically, in a nutshell, we're looking at a novel model where community energy is brought together in terms of energy outside of the boundary area, but also energy within the boundary area on rooftops. That's aggregated rooftops on the terraced homes and other rooftops in nearby. For example, there's a good commercial building nearby the cluster we've been looking at. EV charging, the ground source heating array, and also then the design approach to integrating that as a single operating system and integrating that with ENWL system to exploit what could be quite a considerable amount of flexibility that could be delivered from that. So we need to then follow that up and look in more detail at the integration process, also looking at a testing process to de-risk any risks of putting this into real people's homes in the early stages, and looking at more closely at the network management aspect, because it does require a change to the current way that the flexibility market mechanism works. Next slide, please. And as just touched on earlier, we have been soft market testing this, so we are confident the subsystems can all be provided on the market. What we're really interested in is the integration of that. That's commercial and technical integration. We've identified providers that we're looking to take through into the alpha stage. We've had NDA signed with Kenza Utilities and an Urban Chain. We've been talking to the University of Salford about using controlled test facilities with them to test out some of the subsystem components as part of the de-risking strategy. And we've consulted with over 20 organisations that supply different elements of the system in terms of their potential interest in the scheme and what they can provide. And there's been very strong interest and good alignment with that. So building on that, next stage would be then to establish that test environment, to then start to look at the interfaces and to prove out some of this. This isn't about just also evaluating it in isolation on this project. What we're really keen on is cross-project learning. A lot of these organisations and other organisations have been testing different elements of what we've been talking about today in other projects or as part of their product development process. So it's about capturing that learning, not repeating it, but then looking at where there are little gaps that we can identify that we would want to take forward and de-risk. Is that it, Helen? Think.
Yes, I can just talk through the final couple of work packages. So the local authority were a key project partners working closely with the community energy group, and their engagement plan is around how they can use their sort of existing channels and resources to amplify the message of the community energy group, but also align what they're trying to do with what the local authority is already delivering, especially around the provision of fuel poverty services and energy efficiency services. They're also quite a key partner for understanding the planning regulations that are required for installing solar panels and ground source heat pumps, and which authority it is the project needs to talk to. And then the next slide shows that we've also been working, Northern Power Grid are also a project on the partner. They've done a sort of a peer review, so looking at the low voltage, the connection study that my colleagues carried out to see what we've done to try and integrate it into the network, but also to compare how it works across the two DNOs. And we've discovered that there are slight differences in the processes for how projects like this are considered to be connected to our different networks. So the headlines are that projects like this can go ahead in both areas, but due to those slight differences, you might get slightly a different outcome on the connections process. So that gives us something to look at in further phases to see whether there needs to be some industry standardisation across those areas. And then I think the next slide takes us on to what our next steps are. So we want to go forward for an alpha phase application, and what we want to do is to sort of further test and develop the idea. So around that community engagement, that is taking that engagement plan that's been developed and looking to test the various different engagement methods. So working with a new partner, the Centre for Energy Equality, looking at how the Fairer Warmth app compares as an engagement method compared to sort of more traditional methods, and how we can keep people along all the way through the journey to get them to be really brought into and signing up to the project. We also need to look further at the systems design and integration, so and a fair bit of subsystem testing about that as part of that, as Phil mentioned, so bringing in the University of Salford as a project partner, but also the supply chain partners of Kenza and Urban Chain as well. And then looking further around the DNO DSO integration, what do we need to do to sort of standardise our approach across DNOs for this, but also maximise the benefits of flexibility that this could bring to the network, and make sure that all customers are benefiting from this. So we've got the least cost solution going in, and it's having the greatest impact on the network. And then we'll be looking at learning and scalability. So there's quite a few projects out there at the moment looking at decarbonisation of heat in an urban as well, in sort of household setting. So working with UKPN as a new partner to look at what we can learn from other similar projects, but also how we can scale it, because the point of this is to develop a solution that can be rolled out and delivered hopefully at pace, because as we all know, the earlier we save carbon, the more value that has and the better it will be for all of us. So yeah, how can we roll out and scale it up? And I think that's it from us. But we can take questions, and I think Kate from Rosendale Energy is also here to field any questions about that.
Great. So we have a question here for Phil. How big do you expect the ambient loop clusters to be? Tens of houses, hundreds?
Well, in a way, it's actually both, because we're targeting hundreds of homes, but we can connect street by street, which is tens of homes. So the scale of the overall deployment for each cluster is hundreds of homes.
Cool. Another question here. Is the spatial planning not just the next branding of local area energy planning? They're asking when it's going to be operationalized in this way.
I can answer that, because we do a lot of local area energy planning as well. It is different. It's very complementary. So ideally, local area energy planning should be looking at quite a wide regional perspective in terms of what the possible and right solutions are for deployment. But that planning process needs to be complemented by very granular, on the ground, as it were, planning, and the methodology we have combined that in. So you're looking at LV network, you're integrating direct consumer engagement, you're looking at buildings. We haven't mentioned the whole process here because it's a snapshot, but we are incorporating building survey data into this as well to get better benchmarking and performance data. That's not done under local area energy planning. We are looking at street works and infrastructure planning. Again, that's not done under local area energy planning, but there's no reason why these two planning processes can't work in conjunction with each other to one inform the other. So again, that's part of what we're looking at.
Thanks. Question here. Have you considered solar thermal or PVT to feed into the GSHP, 3 to 4 times more efficient in heating water than PV? Quite technical question there.
We looked at that under a previous study for this scheme, and we came up with the evaluation that actually, with the efficiency of the groundwater scheme in conjunction with the rooftop generation, that was the best fit. If you didn't have the groundwater scheme, or you were looking to feed more heat into the ground perhaps and create larger heat sources, then you could try and leverage more thermal. But what you're trying to do is really get the case for the ground source to stack up. And then we supplement that with base load and powering the heat pumps themselves as the primary user of the energy.